Hi guys, this video today is going to talk about the properties of logarithms. We have been talking a little bit about logs, and sometimes it helps to be able to express things in a different way, whether it's to expand something or make something smaller. And so that's kind of what we're going to talk about. To do that though, I want to go backwards and talk about exponential properties. And so if you look at this table, do you remember the rules for how to simplify these? Pause the video and see if you remember how to do this. Okay, let's take a look at what we have. When you multiply, you're supposed to add them together and you get 5, which as a rule would be stated this way. When you divide, you're supposed to subtract, and so here's your rule. And when you have a power of a power, you're supposed to multiply those together, and that would give you x to the 15th. And so this is your general rule. A way that I have of remembering those is that you basically are taking PEMDAS and you're going like one level down. So when it's an exponent of an exponent, you multiply. So here's an exponent, you're going to multiply. When it's multiplying like this, you're going to add. And when it's dividing like this, you're going to subtract. That's just an easy way I have of remembering it. I just think of it as one level down from PEMDAS. Okay, those rules are the same rules, basically, kind of, as log properties. So we know that exponents or logs are inverses of each other. And so if they are inverses of each other, then kind of the same rules that you have here are going to apply here. They just might be backwards in a way. And so what we're going to do is we're going to take these and expand them out. Like, see how this one was longer and we made it into 1, and this one had 2 and we made it into 1, and so forth? We're going to do a similar thing. We have a single log here. We're going to rewrite it as 2 logs. And so if we think of these rules, this is multiplying, and so we're going to change it into adding. So it's going to be the log base b of m plus the log base b of n. We just took that single log and we rewrote it so that it has 2 logs in it. We broke it apart. That actually is called expanding. What I've done in this table is I give us, like I did up here, I give us one with variables and then one with numbers. And in just a second, I'm going to show you on your calculator how to do this to kind of double check for one. So here we have log base 4 of 5 times 3. We're going to break that up. One thing is you keep the log base the same. So it was log base 4. I'm going to keep it log base 4 here, and I'm going to keep it log base 4 here. And then it's going to be the log base 4 of 5 plus the log base 4 of 3. Okay, I've been talking for a couple weeks now about how to use your calculator, and that some stuff you ought to memorize. And some stuff you'll need your calculator for. So for instance, log base 3, isn't this really the log base 3 of 15? I mean the log base 4 of 15. And so this log, we don't know this. It's going to be a decimal. If it was 16, it would be 2, because before the second is 16. But it's not 16, it's 15, and so it is a decimal. We don't know what it is. Let me show you on your calculator how to do. I'm going to do a couple things. I'm going to do this one, log base 4 of 15. I'm going to do log base 4 of 5 times 3. And I'm going to do log base 4 of 5 plus log base 4 of 3. Okay, so on your calculator, the way you get to it, it is hidden. It is quite hidden. There is a math button over here. So we're going to go to math. And you could scroll down. And eventually, when you keep scrolling, you'll get down to log base blank. Another way that I do it, I'm going to quit out of this and show you again. So a little bit of a shortcut is if you go to this math button, and instead of going down all the way, I just go up 2. And that gets me there. That's just a little bit shorter. So log base, that's what we're looking for, log base. When we hit enter, we're going to get a log base like this. And that's helpful, right? That's what we're looking for. And so we had on our paper a second ago, log base 4 of 15. And I said we don't know, because if it was 16, it would be 2. But it's 15. It's really close to 2, but it's not quite, 1.95. We also had on our paper, I'm going to have to go to that log base button again. So I'm going to go to math, I'm going to go up 2, and I get my log base. I'm going to do log base 4 of 3 times 5. It's the same thing, of course. I mean, that makes sense to us. But then we learned about this expanding, so I'm going to do it also. So I'm going to go back to math, log base. And what we had was log base 4 of 3. And then I have to come out of it and say plus, And now I'm going to do log base 4 of 5. So I went back to the math button, log base 4 of 5, and I'm going to hit enter, and it is the exact same thing. So this button, this math and then log base button, is how you find that decimal answer. If we ever had a test on this, we would probably have a calculator part and a no calculator part. And for the calculator part, you would do things like this. For the no calculator part, you would be expected to know how to do some of those logs that we've done that you can do in your head. Let's go back to the paper. Okay, so what I just did was I'm trying to kind of prove to you or show you that these are working. Okay, let's go on to the next one. The next property is m over n, and so that's a division. For division, we do subtraction. And so for our subtraction, we're going to take log base b of m minus the log base b of n. And so we can break that up that way. This one, again, if I simplified this, I know that this is actually log base 2 of 10. But once again, I don't know in my head what that is. It's a decimal value because 2 to the 3rd is 8 and 2 to the 4th is 16. So it's close to 3, somewhere between 3 and 4, but closer to 3. But I can rewrite it as this. I have to keep that same base. So I have log base 2 of 20 minus log base 2 of 2. And then finally, this last example is not quite as obvious. We're going to use this exponent multiply thing. So this is an exponent. We're going to change it into multiplication. And so we get x times the log base b of m. And so if it was written this way, we would say 3 times the log base 5 of 15. Okay, these rules, these properties are ones that you have to memorize. This little mnemonic, it's not really a mnemonic, but sort of, is going to maybe help you to do that. The reason we do that is kind of like I was trying to show some examples here where maybe you didn't know log base 4 of 15, but maybe you were able to break it up to where you knew what the log base 4 of 5 was and you knew what the log base 4 of 3 was. Now, this example didn't work out that way, but what I'm saying is sometimes we need another way to express them, and it's easier to express them one way or another. Same thing here. We have our exponents. Sometimes we want to express it this way for one reason, but another time we might want to express it this way for a different reason. And I mentioned at the beginning that when we are going from this form over to this form, it's called expanding because we have one log and we're making it into several logs. We can also go the other way. And if we go the other way, that's called condensing. And that's when we have a longer expression like this, and we're condensing it down to a single log. Okay, now that we've done some examples, we know the rules, now let's try to see how they come out. So these type of problems are type of problems you would see in a math textbook or any kind of math problem that you would have. So this is a division problem. Division means subtract. So we're going to start off with log base 5 of x, and we're going to subtract log base 5 of y. These next three all have more than one going on at the same time, and that's the deal. These just had one thing going on, and even these just had one thing going on. But we've taken tests before in this class where you might have 2xy squared over 5x to the 3rd y. And you have to do all of that together. So we know the basic rules, but then we have to put them together. So that's what's going on with these three examples. We know the basic rules, and now we have to put them together. So let's just take a look at number 2. This is really a multiplication problem, right? There's a times between that 3 and r. So if it's a multiplication, that means we are supposed to add. Now we're not quite done because we have an exponent that we need to break up as well. The rule in exponents is we bring it out to the front and we turn it into a multiplication problem. And so our final answer is log base 3 plus 4 times the log. And so our final answer is log of 3 plus 4 times the log of r. And one thing I didn't mention here is what is the base of this? Like this one was log base 5. What's the log base here? We don't usually write it in, and we don't have to write it in, but it is 10. When it's not written in, that means log base 10. Let's take a look at number 3 together, and then I'm going to have you do the next one on your own. So number 3, the first thing I'm going to do is I'm going to go ahead and multiply that. Like that, y over 3 to the second means y over 3 times y over 3, and that's y to the second over 9. So that's my first step. Now I know it's a division problem, so I'm going to do my subtraction. And finally, I have that exponent. Exponent has to come out front. And so my final answer is 2 times the natural log of y minus the natural log of 9. Okay, this next one is the one I was saying, why don't you take a minute and try this on your own and see what you can come up with. Let me also talk about this one we talked about was log base 10. Natural log, remember the equivalent for the natural log is the log base e. So we don't write it log base e, we just write it natural log, but that's what is going on there. Okay, so I started with this and changed it into subtraction. We have a division bar, which means subtraction. So I have the natural log of 3y minus the natural log of x. Then I have to break up my 3y because that's really 3 times y, right? So that's a times, that means plus. So my final answer is natural log of 3 plus the natural log of y minus the natural log of x. Okay, let's turn the page. We've got a couple more examples. I think you guys can do number 5, and then maybe number 6 we can do together. Try number 5. Okay, for number 5, I broke up this into an addition problem, and this is a subtraction. So here's my addition, here's my subtraction. Then each of those exponents has to come out front. So your final answer, 3 log x plus 4 log y minus 5 log z. Number 6, maybe we should look at number 6 together because there's that square root in there. Remember that the square root of x is the same as x to the 1/2 power. So square root is really just a 1/2 power. So if we do this, I'm going to turn this into a multiplication, which is addition, and then I have subtraction, which is division, or division, which is subtraction. Okay, so my first step, I'm not done yet, but my first step is going to be to go log OR plus the log of square root 5, because that's multiplication, minus the log of s squared. Now I'm going to take this power, which is 1/2 power, and I'm going to take this power, and I'm going to expand this a little bit more. So your final answer, the log of r plus 1/2 the log of 5 minus 2 times the log of s. Okay, those all were expanding. Now we're going to go the other way. And by that, I mean we're going to do condensing. And by condensing, it means you have several logs and you're going to turn it into a single log. And so once again, the first one's going to be our easier one. They're both the same base. They have to be the same base. So we have log base 3. I have a subtraction, and I have to remember that subtraction means division. Log base 3 of 20 minus the log base 3 of 4 really means the log base 3 of 5. And once again, you could go to your calculator and plug this in and plug this in and see if you get the same answer. And you should get the same answer. All right, number 2, once again, we have the same log. We have a multiplication. Addition means multiplication. We also have a 3 out front, which means exponent. So we have the log base 2 of x to the 3rd, and then we have a times y. The whole concept is to take an expression that had several logs and turn it into an expression with just one log. So I put all those together. I could have done it in a couple of steps, but I just went ahead and did all in one step. Let's take a look at number 3. Okay, so once again, this is going to be an exponent. This is going to be a division. This is going to be a multiplication. I might take this in a couple steps so you guys can see what I'm doing here. So this is the log base 2, the log of 2 to the 3rd power. And so I'm just going to bring down those other ones. All right, log of 2 to the 3rd is really the log of 8. All right, now these are all just kind of one level, right? There's no exponents or anything. So now I can put these together, and I'm just going to combine them into a single log. So I have 8 times 4 divided by 16, which is 32 over 16, which is really just the log of 2. And again, if you don't trust your answer, you can plug this into your calculator, see what you get, plug this into your calculator, see what you get, and you should get the same thing. Okay, a minute ago we talked about square root was the 1/2 power. The 1/4 power is the 4th root. So this is going to be the log base 3 of the 4th root of 2 plus the log base 3 of the 4th root of x. It is a plus. For plus, we multiply together. When we multiply radicals, if they're the same root, which these are, we can just put them together. And so we get log base 3 of the 4th root of 2x. I'm sorry, yeah. So we can put them together, we get log base 3 of the 4th root of 2x. Okay, if something is in parentheses, obviously that only applies to those, right? So these are each going to be the square rooted, because 1/2 power is a square root. And then this one's going to be to the 3rd power. I'm going to take this in a couple of steps. And there's always more than one way to do a problem. So if you had put these together first and then taken the square root of that, you could have done that, but I just did it this way. So now they're all log base x. Plus is going to be multiply, minus is going to be subtract. And the square root of 4, what's the square root of 4? It's just 2. So we have 2 root y on the top, and then minus means divide, and we have z to the 3rd on the bottom. And that's our final answer. Okay, one last problem. Again, several combinations. Why don't you give this one a try, and then I'll talk about it when you get through. Okay, this is 3 to the 2nd, this is square root 4, this is square root 9. 3 to the 2nd is 9, square root 4 is 2, and square root 9 is 3. Now, we need to put those all together. So 9 divided by 2 times 3. So we have 9 divided by 2 times 3, that is 27 over 2. And that again is your final answer. All right, we worked through a lot of examples. Why don't you take a minute to just write some kind of summary in there so you can remember how to do some of these.